Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss class 12 physics get more than 95% marks. Chapter name is Electromagnetic Waves, Chapter 8 NCERT Line by Line, Part 4. Before we begin today's class, we request you to subscribe our YouTube channel Experience Tutor. Please like and share our videos as much as possible, which will help us to grow, and please click on the bell icon so that you can get automatic notification whenever a new video is uploaded by us. In this way you will not miss any of our videos. Let us, uh, let us start today's lesson. In the last class we have studied about electromagnetic waves and source and the nature of electromagnetic waves. In today's class, we'll start with few of the numerical example. Example 8.2. A plane electromagnetic wave of frequency is given 25 MHz, travels in a free space along x direction at a particular point in the space and time E is equal to 6.3 J V per m. What is B at that point? At this point. Now, this underlined figure are known to us. So, using equation 8.10, the magnitude of B is equal to E upon C. You have to remember this. Put the value of E, which is given 6.3 volt per meter, and put the value of C, that is 3 into 10 to the power 8 meter per second. After solving it, we get this much, 2.1 into 10 to the power minus 8 Tesla. To find out the direction, we note that the E is along y direction. How come we know y direction? Because due to the unit vector j represents y direction, and the wave propagate along x direction. So therefore B should be in the direction perpendicular to both x and y. Using the vector algebra, E cross B should be along x direction. Since J cross K is equal to I, B is along Z direction. Therefore, B is equal to 2.1 into 10 to the minus 8 K Tesla. K represents the Z axis, unit vector for Z axis. Now, so let us review the sum again. So electric field is given, frequency is given, the wave propagation direction is x direction, direction of electric field E is J. We have to find the value of B at that point. So we know B is equal to E upon C, electric field upon velocity of light, from equation 8.10. So put the value of E and C, we get 2.1 into 10 to the minus 8 Tesla. To find out the direction, we note that E is along y direction, which is given, and the wave is propagating towards x direction. So B should be in a direction which is perpendicular to both x and y, that is z direction. So B should be in z direction, that is k unit vector. It is represented by the unit vector k, and B's value is this, including the direction. Now let us move to the next sum. Example 8.3. The magnetic field in a plane electromagnetic wave is given by By is equal to 2 into 10 to the power minus 7 sine 0.5 multiplied by 10 to the power 3 x plus 1.5 multiplied by 10 to the power 11 t Tesla. What is the wavelength and frequency of the wave? B. Write an expression for the electric field. Comparing the given equation with By is equal to B naught sine 2 pi x by lambda plus t by t, we get lambda is equal to 2 pi upon 0.5 multiplied by 10 to the power 3 m, which is equal to 1.26 centimeter, and 1 upon t is equal to nu, and put the value, so we get 1.5 into 10 to the power 11 upon 2 pi, which is equal to 23.9 gigahertz. So try to understand again. We know this equation. By is equal to B naught sine 2 pi x by lambda plus t by t. Now compare this with the given equation. So what we get here? We get B naught's value as 2 into 10 to the minus 7, and sine, this is 0.5 into 10 to the 3 is will be equal to this value plus 1.5 into 10 to the 11 will be this value. So if you compare it, then 1 by t will be equal to 1.5 here, 1.5 into 10 to the 11 upon 2 pi. Why upon 2 pi? Because in original equation we have upon 2 pi, and upon solving this we get nu is equal to 23.9 gigahertz. So first we have to find the frequency of the wave. What is the wavelength? And lambda. Lambda is equal to 2 pi upon 0.5 into 10 to the 3. Why? If you compare this equation, so this this part will be equal to this part. So you write it here as 2 pi x upon lambda is equal to 0.5 multiplied by 10 to the power 3 x. So x get cancelled. So if we want to find lambda, then we can write lambda is equal to point for lambda is equal to 2 pi, lambda is equal to 2 pi upon 0.5 into 10 to the power 3, and upon solving we get 1.26 centimeter. Why? Because this is in meter. You can write it in meter also. So we got the value of lambda as this. We got the value again, t's value. T's value, you compare the equation, so we get 2 pi t upon t is equal to 1.5 multiplied by 10 to the power 11 t. Cancel it. Now t will be equal to t will be equal to 2 pi 1.5 into 10 to the power 11. So 1 by t will be equal to 1.5 into 10 to the power 11 upon 2 pi, and instead of 1 by t we can write nu is equal to, upon solving we get how much, 23.9 gigahertz. So this is the total calculation. Now we have to find write the expression for the electric field. Fine. E naught is equal to B naught C. We know that. So B naught is given to you and C is also given to you. We found the value of E naught. Fine. The electric field component is perpendicular to the direction of the propagation and the direction of the magnetic field. Therefore, the electric field component along z-axis is obtained as Ez is equal to, now E naught, instead of E naught, what we'll write? We'll write 60. How come 60? This is equal to 60. So, and 0.5 into 10 to the power 3 x is already given in the equation here, plus 1.5 into 10 to the power 11 t is also given here in this equation, and volt per meter. This is the electric equation of the electric field, and that's it. So again, let us review this. Just we know that by is equal to b naught sine 2 pi x by lambda plus t by t. Now we are comparing this with this equation. Upon comparing, we got lambda is equal to 2 pi upon 0.5 into 10 to the power 3, and which gives to 1.26 centimeter. Again 1 by t is equal to nu is equal to 1.5 into 10 to the power 11 upon 2 pi and 23.9 gigahertz. Then now this is lambda and nu which we have found. Now we have to mm, find E naught. E naught is equal to B naught C. So put the values B naught C. We get 6 into 10 to the power 1 volt per meter, or 60 also you can write. So electric field components are perpendicular to the direction of the propagation and the direction of the magnetic field. Therefore, electric field components along z-axis is obtained as Ez is equal to E naught. E naught we have put the value 60 sine 0.5 into 10 to the power 3x, which came from this equation, and 1 plus 1.5 into 10 to the power 11 t. This also came from this equation, and that's it. Let us move forward. Okay, example 8.4. Light with an energy flux of 18 watt per centimeter square falls on a non-reflecting surface at normal incidence. If the surface has an area 20 centimeters square, find the average force exerted on the surface during the 30-minute time span. So time is also given to you. Fine. The total energy falls on the surface U is equal to 18 watt per centimeter square. It is given from here. And area is also given 20 centimeters. So total energy falling multiplied by area. Then and time is also given. time is 30 minutes. 30 minutes we have converted into seconds. So we got total energy falling on the surface for 30 minutes, that is 6.48 into 10 to the power 5 joule. Therefore, the total momentum delivered for complete absorption is momentum P is equal to U by C. Put the value of U and C, you get momentum as 2.16 into 10 to the power minus 3 kg meter per second. The average force exerted on the surface F is equal to P by T, the momentum upon time, that is uh, 2 into so put the value of momentum what you have found here, this value upon times value, you just put it times time, how much time it is. So we get 1.2 into 10 to the power minus 6 Newton. So again, let us review it. First we find out the energy, total energy. So we'll multiply energy and flux into area into time. So we get the total energy. Now you have to find the momentum. So momentum is equal to total energy upon C. We got the momentum after calculating. Then we have to find F. Then momentum upon time is F is equal to momentum upon time. Put the value of momentum and time. We get the value of momentum. We get the value of force. And let us move to the next question, that is 8.5. Calculate the electromagnetic field produced by the radiation coming from a bulb 100 watt bulb at a distance of 3 meter. Assume that efficiency of the bulb is 2.5%. It is a point source. The bulb as a point source radiates light in all directions uniformly. At a distance of 3 meter, the surface area of the surrounding sphere is A is equal to 4 pi r square, that is 4 pi 3 square, that is 113 meter square. The intensity of this distance is I is equal to power upon area. So put the value of power, and 2.5% is given, so multiply it by 2.5% up, and area is also given to you 113 meters square. You got the intensity, that is 0.22 watt per meter square. Half to this intensity is provided by the electric field and half by the magnetic field. So half of this intensity is equal to half of epsilon naught E RMS square C. So if we want to find out the intensity by the electric current, then we have to write half of intensity, total intensity. So which is equal to half of 0.02222, which is equal to 0.011 watt per meter square. So this is the intensity due to the electric field. Now this is equal to half of epsilon naught E RMS square and C, which is equal to so we can write so we can write 0.011 is equal to half epsilon naught E RMS square C. So ERMS is equal to under root 0.022 upon, put the value of epsilon naught, that is 8.85 into 10 to the power minus 12, put the value of C, that is 3 into 10 to the power 8, and upon solving we get 2.9 volt per meter. This is the calculation for ERMS. The value of E found above the root mean square value of the electric field. Since the electric field is in a light beam of sinusoidal, the peak electric field E naught is equal to root 2 RMS, which is equal to root 2 into 2.9 volt per meter, this one. So ultimately the value of E naught is 4 into 4.07 volt per meter. Thus you can see the electric field strength of the light that you use for reading is fairly large. Compare it with the electric field strength of TV and or FM wave, which is of order of few microvolt per meter. Now let us calculate the strength of the magnetic field. So BRMS is equal to ERMS upon C. Put the value of ERMS, that is 2.9. Just now we have find out the value of ERMS, and put the value of C, that is 3 into 10 to the minus 8 meter per second, and we get 9.6 into 10 to the minus 9 Tesla. Since the field is a light beam, is sinusoidal, the peak magnetic field is B naught is equal to root 2 RMS. So put the value of root 2 RMS and we get 1.5 into 10 to the 8 Tesla. Note that although the energy in the magnetic field is equal to the energy in the electric field, the magnetic field strength is evidently very weak. So let us review the sum again. So first we will find the area, that is 4 pi r square, 4 pi, and put the value of r, that is 113 meters square. Then we will find the intensity. Intensity is equal to power upon area. Put the value of r, multiply by 2.5% upon 113 meters square, and we got the intensity. Half of the intensity is powered by the electric field and half of it is magnetic field. Therefore half of I is equal to half of epsilon naught ERMS square upon C. Put the value of ERMS square. Put the value of I, half into I, and then if you solve for ERMS, then under root 0.022 upon 8.85 into 10, this is the value of epsilon naught, and C 3 into 10 to the 10 to the 8 meter per second is the value of velocity of light. Upon solving we get 2.9 volt per meter. Now if we want to find out the E naught, then it will be, the formula will be root 2 E RMS, root 2 E RMS. So put the value of root 2 and E RMS value is 2.9 volt per meter, then we get a value 4.7 meter per second. So now we have already found E naught's value. Now BRMS is equal to ERMS upon C. Put the value of ERMS and then value of C, we get some 9.6 into 10 to the minus 9 Tesla. Again, since the field in the light beam is sinusoidal and peak magnetic field is B naught is equal to under root B RMS, which is equal to 1.4 into 10 to the minus 8 Tesla. Note that although the energy in the magnetic field is equal to the energy in the electric field, the magnetic field strength is evidently very weak. And let us skip today's class till here. In the next class, we'll start with 8.4 electromagnetic spectrum. Before we close our today's session, we request you to subscribe our YouTube channel, Experience Tutor, and like and share our videos as much as possible. Also click on the bell icon so that you can get automatic notification whenever a new video is uploaded by us. Thank you for supporting us and watching our videos. Thank you very much.